I think we covered this question. I know we are running over time, but I really want us to go over the next slide as well, which is related to IVRT sample analysis. If you can click on all the points and so in terms of what analytical method validation should be for IVRT is should people follow the guidance for bioanalytical method validation? Can they use single point calibration curve for the IVRT? What is the guidance that they need to follow, and what amount of validation is needed for the analytical method that is used for the IVRT? Anyone wants to chime in?
I think everyone's tired.
I know.
It would be good to get a clarification here, because I think we got a deficiency way back in 2015, or right after acyclovir came guidance, so 2016, because we had used ICH guidelines for validating HPLC method. Then we were asked to go back and revalidate the HPLC method using bioanalytical method validation guidelines, because it fell into the bioequivalence division. And so it's good to have a clarity on what one should use. And I will say this, my personal opinion is that once the HPLC method demonstrates linearity over the range of concentration, then why would we need to do the standard curve every time? And why would we not use a one bracketing standard? There are so many samples to analyze. HPLC is a long runs. And then we also have these requirements of, well, I guess I can live with the QC samples being asked to be analyzed, because that's important. But anyway, it would be good to know what some of the agency folks think about this.
We also been asked to follow bioanalytical method validation, and we do it. Quite challenging sometimes. Let's say the standard preparation should not be the need. It should be treated by the placebo, which is in method of the bioanalytical method validation. Sometimes when the IVRT method used for a bioequivalence study, I understood, but in a QC release or stability studies, maybe there's some flexibility we should have, like follow ICH guideline instead of bioanalytical method.
Any of our FDA colleagues would like to share their opinion?
Well, I'm actually more interested in well, in my career, following the bioanalytical method validation guidance was not a problem for IVRT studies. There's a lot involved there, but it's not a challenge. I am more interested, rather than kind of saying, well, this is my opinion. I'm kind of interested to understand what the challenges, Theo, that you've experienced with utilizing those recommendations for the HPLs. It's what the bioanalytical method validation guidelines.
Well, it's not a challenge, but it's a lot of work. It's much more work. You need the solution integrity, the other part, and it's a lot of requirements there. The problem is not technically, it's not a problem.
Okay, yeah, I agree. I don't think technically it's a problem. I agree. It is work, but then I also kind of struggle. So if you dilute your samples, but you don't have dilution integrity.
Yeah. And the QC, you have to make not the need solution.
Yeah, so that's something that we see as a challenge, that collecting that amount of PRS solution, of placebo receptor solution, to use as a solvent takes a lot of resources. It takes a lot of time. It's almost doubles the amount of time that it takes to do any one study. So we see that. And we also see that sometimes excipients come through in the PRS
So
solution.
sorry, I'm having trouble hearing. You also see that excipients, sorry, can you say that again?
Yeah, there's sometimes, is that better?
Yeah, it's better.
That sometimes excipients come through in the PRS solution, and then we have a bit of a challenge with, since we have to use that as a solvent, what that does to our instruments, to our HPLC, lines and things like that, when we have this kind of dirty, QC samples. That's the only thing I would say about the bioanalytical method validation guideline. But apart from that, the linear curve and using that, it definitely makes it a more comfortable method to use. And yeah.
What placebo receiving, when you mean placebo receiving solution, let's clarify that what the practice is to apply the placebo on the vertical diffusion cells and collect the receiving medium that and then use that as the solvent for QCs and making QC samples for the entire validation pivotal comparison. So that's the time consuming part.
Correct. So exactly. It's like running a whole study just without sampling. At the very end, you just collect and combine all of the solution that the receiving media that has been exposed to this placebo. And that, you have to collect quite a bit because especially for the validation, you have 5 stocks, and from each of those 4 QC samples. So, that takes a lot of PR solution. But I would just, count that as a challenge, not exactly that it should not be used, but.
So
Yeah.
we build.
I appreciate the point.
Yeah, that it's a timing.
I think, as an outcome of this workshop, we definitely want to understand and have a chance to have a dialogue about these the challenges and see if there are opportunities to streamline things by considering, okay, what's the risk associated with doing things in a more efficient way? For the most part, these are pretty clean samples. For the most part, one could probably just look at the naive receptor solution, and there are situations, and I think what you're doing is highly laudable. I've had experiences myself where the receptor solution solubility for a drug was lower than my sample concentrations. And I thought, well, how can this be? Well, it's because there was a component in the vehicle that was rendering the drug to be soluble in the vehicle, and that component was permeating into the diffusion cell and providing fantastic solubility for the drug in that receptor compartment, which is why the native receptor didn't have very good solubility, but I had. So you're absolutely right that this is it's an ideal way to think about this. It's a good way to think about the fact that your medium, your matrix, is actually not the naive receptor solution, but it's the receptor solution that may have received a significant amount of excipients as well. But I think most of the time, these are relatively clean samples,
Right.
and it may be sufficient to just say, I don't know if you need to do that placebo every time. I think it's scientifically, everything's correct about what you're doing. But is there a streamlined way that we maybe don't need that? Maybe it's sufficient to just say, I've done my bioanalytical method validation with my naive receptor solution samples. I think there's definitely room for that kind of, at least just me speaking personally. I'd be interested in thoughts from the rest of the group, and I know we're over time. But I think these are areas where, as we move forward, if there are opportunities to say we can make substantial improvements in efficiency, substantial reductions in cost, maintain essentially all of the quality, and reduce, reduce the risk of things that really concern us, focus on those things rather than just progressively expanding the amount of work that we need and the effort associated with these things. And I'm very open to learning more about what your recommendations would be in those areas. I'm not sure, Hiran, Josephine, Abhishek, if you have some thoughts.
I have a question. Sorry, go ahead, Kailas.
My suggestion was that we can have a middle ground where we don't have to do all of the validation using the PRS collection, but we show that for one of the validation runs and then carry on and show that there is no effect, or that everything runs the same release rate, stability, etc., etc. And then for the rest of the validation, because that would save a significant amount of time to validate a method.
So I have a question. Because we are talking about two things, we are talking about the making a placebo solution, and the second thing is are we talking about the number of injections? Because even if you go for the single point calibration, you inject that sample 5 or 6 times as a part of, just assuring there's a precision. So what is the major concern? Is it having some longer run? But that's the same for even single point calibrator, because it's not like you are injecting only one sample one time. Even if you go for a single point calibration, there are multiple injections on that one. So go ahead.
No, I think what Christina is referring to is not the number of injections, but the time taken to collect the placebo receiving solution, because we have between 8 to 12 mils per diffusion cell. And apparently you need a lot more placebo receiving solution to be able to conduct that entire validation activity. And so it takes us, I don't know, whatever time it takes to Christina's group to collect this placebo receiving solution to then use it for preparing all the QC samples and the standard curve and everything. Am I right, Christina?
That's correct.
So it's a timing. It's that before doing the validation, here's the situation. But I think what happens, let's say we have a sponsor, we are validating an IVRT method for VAB waiver, and our protocol has been signed off by the sponsor. Then Christina's group comes along. She comes along and say, okay, now let's start collecting PRS first, and that's the first activity that needs to happen. So we have to build the time required to that almost non-activity for which, and then we cannot start validation activity until she has enough placebo receiving solution collected for the entire validation. So how long does it take for you to validate a method generally?
Right. So think,
8 weeks?
for every run that we do, for every study that we do, typically we have to spend one entire day of work, since they're 4 to 6 hour run times collecting PRS. That was the
So let me ask you. I think scientifically what you're doing is laudable. I think if you did it with naive receptor solution rather than the placebo receptor solution, I think the risk to the study in most instances would be relatively low. The challenge is that I feel like what you're doing is sort of a middle ground, because the instance that I ran into, which typically I would not evaluate I would not generate placebo receptor solution for an IVRT study. In those situations where something anomalous was happening and I realized I needed that, then it got super complicated, because I realized I don't just have one matrix. I've got a different matrix at every single time point, because the amount of placebo mixing into my receptor solution at every time point is different. And so it wasn't just 1 6-hour run and I get my placebo receptor solution. I essentially had this expansive study that I had to do then to get solubility data at every single time point, and I had all of these matrices to validate. So, I'm not a big proponent of going down that road unless you really see in evidence that it's necessary, and it's the occasional dosage form. My position is, I think it's okay to not have to do placebo RS routinely, but to do it as an exception when necessary, to be able to explain, that you have something unique going on in that situation.
That's much better.
But just my opinion. This is not the opinion of the FDA. Really say.
As long as it's accepted. Well, I think keeping it till 6 hours, going up to 6 hours is the worst case scenario, Sam, because then you have the maximum number of excipients or whatever that's going to diffuse through, and then you use that particular matrix to determine to do your QCs and stuff like that. And that we do that for specificity of HPLC method all the time, but this is for BAB waiver methods. We also do that for QC for preparing QCs and other solvents or solutions.
And I agree. I do share the
sorry.
same. I do share the same opinion as Sam, that as a part of analytical method validation, if you work it out, if you validate the validation, and if you source the data that there is no impact of that matrix on the quantification of your analyte, I mean, scientifically speaking, again, I'm keeping the regulatory head on the side, but scientifically speaking, I don't see a concern, or as a even reviewer, if there is no impact on the quantification of your API in the presence of matrix, in the absence of matrix, I think your method is well validated. And when you conduct the actual study, it should be okay to have just using the receptor solution, because it was already demonstrated that there was no impact on the quantitation of that API in the receptor solution. So I don't see any major concern there. And what Christina is saying, that I appreciate the efforts behind that one, but that may be specific consideration for any unique formulation, but majority of the time, I mean, as long as you have a good validation, I don't see any concern. And again, what is mentioned in the bioanalytical method validation, some of the parameters may not be even applicable to the in vitro study. But as a reviewer, when you look at the calibration curve with the multi-point calibration, and you are using the recursion-based back calculation, that gives us more confidence rather than we go with the single calibrator and you go with the ratio-based back calculation. Because when you go on the lower side, again, we are working with the unknown sample. So, I know there was 1 or 2 times shows that there's a linearity, but as a reviewer, when I see the single point calibration, it's just, on a lower side, I'm a little bit concerned, or, whether it's going to, I mean, there's a scientific question that whether it's going to impact the release rate. I don't know whether it's going to impact the release rate significantly, but just to have, this is, to support the equivalence, and if you can accurately quantify those API, that will be great. So I think I personally like, take some of the concept from the bioanalytical method validation and just validate your method accordingly. But again, I mean, this is kind of open-ended. This is just my thought.
Well, that's comforting.
Any final comments on that? Because we are running way over time.